This simple device measures the thrust of the motor and prop combination. It's very easy to build and very cheap. The button on the left turns it into the manual mode, and turning the pot will cause the motor to turn. On the computer screen you can see the ESC drive value, the battery volts, the battery amps and the number of blades turning per second. Increasing the pot will increase the motor speed, and of course it's measured on the computer screen. There is also an automatic mode. If I press this button here, device there that measures the thrust. So in the automatic mode, if I press this button here, at the end of the beep it increases the drive to the ESC in steps of 5%, and it outputs the voltage, current, ESC drive and prop speed to the SD card here. At each beep it indicates when you should manually read the thrust value on the digital scale. We're at about 50% now, and I'll just stop it there. The data from the SD card has been input to a spreadsheet. This column is the ESC drive. This is the voltage of the battery, the current that is drawn, the number of blades that are turning per second, the thrust in grams, the number of props that are on, the number of blades that are on the propeller. It then calculates the RPM from that and that, calculates the watts drawn from the voltage and current, calculates the thrust per watt from the thrust and the watts. We can use these figures then to display various graphs. This is the graph of the thrust and RPM against the ESC output. This is the graph of the current and thrust against ESC output, and we've got the thrust and power again against the ESC output, and we've then got the thrust per watt against ESC output. This is a rather crude but effective thrust measurement for the motor and propeller combination. We have here a load cell that has been taken out of a digital scale, and I've got the electronics of the digital scale here. So as the propeller turns, the load cell provides the thrust of the combination in terms of grams. I have here a Hall effect current sensor for measuring the current that the motor and propeller combination are taking, and a voltage divider here so that the Arduino can measure the voltage of the battery. The Arduino, of course, controls the whole thing, providing PWM pulses to the ESC, which drives the motor. The propeller speed is measured by means of a laser transmitter, which is the bottom of those two items, and a laser receiver on the top. And as the propeller turns, the beam of the laser transmitter is reflected back to the receiver, and the Arduino can monitor and check the speed of the propeller. There are two buttons. The left hand one turns it into a manual mode. By turning this pot, you then increase the speed of the motor, and the Arduino can output onto the computer screen the current, the voltage, the ESC percentage drive, the motor speed, and we will read the thrust in grams manually on this screen here. The second button, if pressed, will put it into an automatic mode, and it drives the ESC in 5% steps from 0 up to 80%, measuring all of those earlier factors and storing them onto this SD card.